So the thing I want you guys to know, what I want you guys to know is that solution is equal to solute plus solvent. Okay? And this solvent was water, so it gets a special name, aqueous solution. Okay? So I have one with water, I have one with sugar in it. I didn't label it, but we have two beakers here, one with solvent alone and one with solvent plus solute. Okay? Water, solvent, sugar, solute. So let me ask you this. For the beaker that just has water alone, okay, here's a question for you guys. For the beaker that just has water alone, that I didn't add any solute to, that I did not add anything to, okay, what is the boiling point for water? Okay. So right, okay, so water alone, right here to the left, okay, its boiling point will be 100 degrees, okay? Okay, what will its melting point be, water alone? 0 degrees, okay? So, in this beaker that's to the right, I made a solution, we'll put that in red, and that has water in it, right? It has water. But it also has something else in it, and it is the glucose. Okay, the sugar. So it has some stuff in it. So the question for you guys now is, what is the boiling point of this new solution? What is the boiling point of this new homogeneous solution? Is it going to be higher or lower, or will it be the same? Okay, higher or lower? It's going to be higher. Okay, higher. Okay, so one of the things that we want to know, these four things, the boiling point is going to be higher. We call that boiling point elevation. Okay, boiling point, I'll call it BP elevation. Okay, so your new boiling point will be higher. Okay, if I added a little bit, if I added a lot, if I added not just glucose, maybe if I added something totally different, maybe if I added, I don't know, powder, orange powder, if I added poison, okay, whatever it is, okay, if I added rocks, so anything that dissolves, okay, if I add a little bit, if I add a lot, no matter how complicated its structure is, no matter how simple its structure is, I add one drop of it and make a solution, my new boiling point will be higher or lower? Be higher. Okay. So what will my new freezing point be? I'll call it freezing point, actually. Freezing point. What will my new freezing point be? Higher or lower? Okay, it's going to be lower. Okay, this is the second thing I want you to realize. This is called freezing point depression. Freezing point depression. Okay. I'm going to call it FP depression, for freezing point depression. Okay, so it doesn't matter how much I added as long as it's dissolved. It doesn't matter if I add an inch or a pinch or whatever. It doesn't matter how complicated the structure is. Okay, it doesn't matter as long as it dissolves in water. The new solution, okay, compared to solvent by itself, will have a lower freezing point. And chapter 11, we talked about something called vapor pressure. So do you think the vapor pressure would be higher or lower, or would it be the same between these two, solvent alone versus solute plus solvent? It will be lower. Okay, we call that vapor pressure lowering. Okay. Why is the vapor pressure lowered when you add a little bit of solute to the solvent? We call that vapor pressure lowering. Why does the vapor pressure lower? Anybody have any ideas? Okay, what do you need for it to get it to a vapor? You need it to boil. Is it harder to boil two things, or is it harder to boil one thing? This has more IMF than this, because why? There's more. Now you got to overcome water-water hydrogen bonds. You got to overcome sugar-sugar bonds and IMF, and you got to overcome sugar-water IMF. You just got to overcome more IMF. Okay. What IMF do you have to overcome? Just the water-water. Okay, so there's more IMF, so this is harder to boil, harder to evaporate, and if it's harder to evaporate, it's harder to condense, it's harder to exert a vapor pressure, and because it's harder to exert a vapor pressure, the vapor pressure of the solution will go down. Okay. And then the second thing that happens the minute you add a little bit of solute to a solvent is that you'll generate an osmotic pressure. Anybody here biology majors? Okay. So the biology majors, they talk about the cell membrane and stuff. So this is more closely related to that. So you generate osmotic pressure in presence of a semi-permeable membrane. We'll talk about these math problems later. But in the presence of a semi-permeable membrane, you develop an osmotic pressure. And this osmotic pressure, for some strange reason, is called pi. But we'll talk about that towards the end of this chapter. So these are 4 things that happen just because I added some glucose in water. Okay? You have a new boiling point, which is higher. You have a new freezing point, which is lower. You have a new vapor pressure, which is lower. And now do you have, if you put in a cell membrane or any type of membrane in, will you develop a pressure against the sides of those membranes? Yes. Okay. So those are 4 things happen just by adding a little bit of sugar to my water. Okay. Or these 4 things happen if I add a little bit of solute to my solvent. Okay, so we're going to call these 4 properties colligative properties. Colligative properties. Okay, this is a major theme of this chapter, okay, this idea of colligative properties. Colligative means it doesn't matter the structure, it doesn't matter if it's poison that you're putting in or life-giving if you're putting it in. Okay, the minute you add something to a solvent, these 4 things automatically happen. Okay, these 4 things automatically happen. It doesn't matter how complicated the structure is, how simple the structure is, or how whatever it is. Any solid to a solvent, and if you get a solution, okay, these 4 things are going to happen. So can we know these for the exam? Multiple choice. What are these 4 things, colligative properties of a solution? Anybody name one? Without looking at this. What's our new freezing point? Yes. What's our new vapor pressure? Lowers. What's our new boiling point? Higher. And what else do we get if we put in a membrane inside? There you go. You get an osmotic pressure. So these are the 4 things that happen. Okay. All right. So we'll talk more about this later. Let's go to page 2 here. There is some aspects about forming a solution. So I'm going to go over that very briefly, but I'm not really going to test you on it. I added the glucose sugar in water, and it formed a solution. And I just want you to know that sometimes to form a solution, you have to overcome solvent IMF. You have to overcome solute IMF. And then the solute solvent must be greater than these other 2. Okay. So the glucose-water interaction must be greater its interaction must be greater, its delta H, heat, or must be greater than the water and sugar. Okay? So sometimes you need to add heat to that, and we call that endothermic, and sometimes it goes in so well that it gives off heat, and that is exothermic. Okay? So sometimes if you put a solute in a solvent, it gives off heat. And sometimes you put a solute in a solvent, it don't go. Okay? It doesn't go into solution. What do you need to add to get it into solution? If one gives off heat, what does the other one require? Yeah. So when you're dissolving something in water or any solvent, sometimes you need heat, sometimes it just gives off heat. Okay? So that is what I want you to know about that. Okay. Any questions or comments? So what is a solution? What are two things?
Solvent and solvent.
Okay, yeah. And then the minute you make a solution, 4 things happen. I think we went over them. We'll go over them again. What are they? Yes. And what are those 4? Higher boiling point. Lower vapor pressure. Freezing point depression. Lower freezing point. And an osmotic pressure. Okay. And sometimes to make a solution, does it require heat? Yes. Okay. Some solutions we call, requires heat, so that's endothermic. Some solutions, they give off heat. Okay. They give off heat. Okay. So it's just a matter of overcoming the IMF. Okay. Heat can really overcome some of the IMFs. Now let's move on to another topic here, and that is like dissolves like. You know what like dissolves like means? Okay, it means a polar molecule is miscible with a polar molecule, and a nonpolar molecule is miscible with a nonpolar molecule. Okay, this is like dissolves like. So on the exam, we want to know what can dissolve into what. Okay, what can dissolve into what. All right, we call it like dissolves like. Polar goes into polar, nonpolar goes into nonpolar. If polar goes into polar and they mix, what's the term that we use for 2 substances that can mix together? Okay, very good. Okay, and what is the term we use for 2 substances like oil and water that don't go together? All right, I think you guys got that. Good. Okay, immiscible. All right, so without looking at this, okay, I know I gave the answers out, but without looking at this, can you tell me if can C6H6, which is benzene, and water, can they mix? Yes or no? Yes. Okay. No. Okay. Why is it? Now, this is something I want you to know. Why is it that they cannot mix? Which one's nonpolar, Michael? Okay, it's a benzene, and what is water? We should know water is polar. What else can water do? Hydrogen bond. Okay, keep those 2 things. Water is polar, and can hydrogen bond. Keep those 2 things with you from from this class and beyond. Okay, especially the biochem and the pchem and all that. How about benzene and carbon tetrachloride? This may be a little tricky.
Yes.
Yes, both are nonpolar. Both are nonpolar. Okay, right? Everyone know why CCl4 is nonpolar? Okay, the chlorine poles exactly counteract one another. How about water and ethanol? That stands for ethanol. Yes. Okay, polar, both can hydrogen bond. Water and CCl4? No. Carbon tetrachloride is nonpolar. H2O is polar. Do not mix. This benzene and ethanol, no. Okay, benzene is nonpolar, just a bunch of carbons and hydrogens. Don't do anything. This ethanol is polar because of the OH. Okay, ethanol, the OH group. Okay, there you have it. All right, now for something that's a little bit tricky. Okay, one of the more harder aspects of Chem 2, and the idea of concentration. You all remember concentration in Chem 1? That's called molarity. Anyone want to tell me what molarity is? It's a unit of concentration, but what does it actually mean?
Moles per liter.
Moles per liter. That's very good, Allison. Let me make it a little bit more specific. Okay, molarity is moles per liter. It's big M, which is very good, but let's not call it moles per liter, which you're right. Let's be more specific. It's actually moles of solute over or per liter of solution. Okay, we'll go with this one for molarity, big M. Moles of solute over liters of solution. This is what we're going to call molarity. Are we okay with this? All right, that is big M, capital M. Okay, there's something called lowercase m. Okay, this is not molarity. This is where the trickiness comes in. This is called molality. This is something totally new for us in Chem 2. Molality. Okay. Molality is not big M because that's molarity. Molality is moles of solute over kilogram of solvent. Moles of solute, just like molarity, but what is in the denominator? Right, kilograms of solvent. Okay, molarity and molality. Okay, one is lowercase m, the other one is capital M. Capital M. Okay. We have some other ones here that are kind of, basic. Mass percent, okay, mass of solute divided by mass of solution. To get it as a percentage, we multiply it by 100 mass percent. Okay, we have mole fraction, okay, part over whole. Anytime you see this word fraction, it's part over whole. So mole fraction is moles of A divided by moles of A plus moles of C plus moles of B plus moles of D plus moles of E, moles of, all the moles inside the container. And we can also get a percentage, mole percentage, by multiplying it by 1,000. Okay. So this mole fraction and mass percent is also a way to express concentration. There's also parts per million, parts per billion, all those other things as well. Okay, but we will focus here on molarity and molality. What makes this difficult? Okay, what makes this very difficult for our students? Okay, is how to go from one to the other. Okay, can we go from molarity to molality, or can we go from molality to molarity? Okay, the interconversion is what we'll do now. All right, are you ready to do these types of problems? Okay. All right, let's do these types of problems here, and then the next 20 minutes or so. All right, convert 0.396 molal of glucose to molarity. Convert 0.396 molal of glucose to molarity. Okay, the density of glucose is 1.16 grams per mil. Okay, so what is 0.96 molar? What does that actually mean? Okay, well, first of all, what is our solute? Glucose. And what is our solvent? We can assume it's water. Okay, 99% of the time it will be water unless the problem tells you otherwise. So we'll just assume the solvent is water. Okay, distilled water. All right, what does 0.396 molal actually mean? By the way, glucose is C6H12O6. Okay, it's not something you need to know, but that is what glucose is. That's its formula. Okay, what does 0.396 molal of glucose mean? Okay, it means 0.396 moles of glucose per what? That's molar, molarity. So it's per kilogram of water. We'll assume water is our solvent. Okay. Are we okay with that? Yes. That's what 0.396 molal means. It's called molal. Molal. Huh. I don't like the way that's written. Molal. 0.396 molal for molality. All right. So what do we need to convert it to? Molarity. What is molarity now? I think you guys said it. I think you said it. Allison, we'll say it again. It's moles of solute per liter of solution. All right, so this is how we'll do this problem. Kilogram of water, which is our solvent. Isn't the 1 kilogram of water, isn't 1 kilogram of water the same thing as 1,000 grams of water? Yes or no? You agree or you disagree? Okay, agree. Good. Okay. So we have 1,000 grams of solvent. Okay. Let's go ahead and convert this 0.396 moles of glucose into grams of glucose. Okay. Let's go ahead and convert it to grams of glucose. We'll convert that moles of glucose to grams of glucose. All right, so we got 0.396 moles of C6H12O6 times 1 mole of C6H12O6 contains how many grams? About, give or take. You know how to calculate this, right? Carbon is about how much? Look at your periodic tables. Carbon is about 12. What's hydrogen? Okay, 1.01. You read that bottom number in the periodic table. Carbon is about 12.01. Oxygen? 16. Okay, you'll take 16.01 times 6. This is a rough number. 1.01 times 12 plus 12.01 times 6. Okay, you add the numbers up. Okay, when you add the numbers up, I got about 180.04 grams. Okay, 12.01 times 6 plus 1.01 times 12 plus 16.01 times 6. If we add them all together from our periodic table, we'll get the mass in 1 mole and that is about 180.04. The moles cancel. What is this on our calculator? I'm getting 71.29 grams. 71.29 grams. Yes or no? 296. Okay. Any objections? Did you get that? 71.296. All right, so this is the grams of glucose, and that is the solute. Okay. Grams of glucose, which is our solute. Okay, what do we know about a solution? What are its two components? Solute and solvent. Okay, so a solution is equal to solute plus solvent. Okay, we know our solvent is 71.296 grams. Okay, I'm sorry, we know that our solute is 71.296 grams. How much is our solvent? How much? 1,000 grams. So we have our grams of solute plus the grams of solvent. And what is that on our calculator? It's about 1,071.29. 1,071.29 grams of solution. All right. Are we okay? We're almost done with this problem. Going from molality to molarity. Okay, what a pain. Almost done. All right, now we have our grams of solution, and I'm going to go ahead and multiply that by the density that's given to us in the problem. Okay? Actually, I'm not going to multiply it. I'm going to divide it. Okay? So I'm going to take that 1,071.29 grams. Okay, I'll take the 1.16 grams and put it at the bottom, and I'll put the milliliters up on top. Let's go ahead and convert that to liters. So we have 1,000 milliliters is to 1 liter. Okay, so this is the grams of solution will give us the volume of the solution in liters. So what's 1071.29 divided by 1160? Oops. You're getting 0.924 liters. 1,071.29 divided by 1.16 times 1,000. Close the parentheses. 0.924 liters. Okay. And then finally we can get our answer because molarity is moles of solute over liters of solution. So here's our liters of solution right here. We get it from the density. So molarity, which is big M, is moles of solute liters of solution. Our moles of solute is 0.396 moles. And our go ahead. Our liters of solution is 0.924 liters. Yes, go ahead.
Wait, I'm confused. Where did we get the gram solution? Like, where did we get
That's
the
our
second
density.
equation
The density, 1.1 grams per mil.
from? Wait, where did we get the one?
A solution is solute plus solvent. We have 1,000 grams of solvent. 1 kilogram is 1,000 grams. And then we took these moles and converted it to grams, which is the grams of solute.
Wait, where did we get the 1071.2?
We added them because the grams of solution is equal to the grams of solute plus the grams of solvent. So the grams of solvent is 1,000 grams. The grams of solute we get by converting this to grams.
Okay, so how come there's no numbers underneath the ml? I mean, with the ml in that equation.
Because these are grams.
No, like
So
not
from
under
the
the second equation. Yeah,
This one?
Like, how come there's no numbers next to the ml or the ll, or is that a 1?
This is the density. We take our total grams and we divide it by the density to get the grams to cancel. So the density is 1.16 grams per mil, right? So this is the density. It's given to us in the problem. It's 1.16 grams per mil. So this is the density of the solution. Okay. But we just calculated the grams of the solution. Maddie. So we'll take the grams of the solution and then we will divide it by the density. The grams cancel to get it to mils. Right? So 1.16 grams per mil, we'll move that 1.16 to the denominator and mils to the numerator. So the grams cancel. We're left with mils. And then 1 liter is 1,000 milliliters. The mils cancel, leaving us with liters. So the total mass, grams of solution, is the grams of solute, which we got here. Converting the solute to converting this to grams. The grams of solvent, well, mole over kilogram of solvent, 1 kilogram is the same thing as 1,000 grams. So 1,000 grams of solvent plus grams of solute, that's the total gram of solution. Take the total grams of solution, divide it by the density, gives us the volume. Converting that volume to liters. Okay, why did we convert the volume to liters? Because molarity is moles of solute over liters of solution. So our moles of solute is right here, 0.396 moles. And our liters of solution is something we just calculated as 0.924 liters. So we divide our moles, we divide it by the liters of solution, which is what we got here, okay, using the density. And that will be the answer. About 0.43 big M. Is that what you guys got? 0.43? You got that? 0.43. We'll do 3 digits because we have 3 digits here, so we'll do 3 digits there. So 0.429, big M. Okay, so these problems just take a lot of practice. Okay, they're not intuitive. Okay, molality is moles over kilogram of solvent. Okay, 1 kilogram is 1,000 grams of solvent. We get the grams of solute, add them together. And then we got our grams. We use the density to get the volume. All right. Any comments or questions on this? I can meet you after class also if you need more help.
Because I'm just really confused. I've never done this before.
Because for the density, it's like density is always equal to mass, or the volume is the, I'm confusing the density thing, because it's like,
It's mass over volume,
Yeah.
but to get to but you can get volume from the density
so
if you
that's what
divide
I'm
it.
doing this version.
That's what you're doing in this equation. Yes. Have you know this triangle? Density, mass over. Oh yeah. Yeah. You can get the volume, you can get the mass, or you can get the density. So here we're getting the volume. Right? We can do a couple of more also. Okay, we have a couple of more to do. All right, any other questions? All right, let's do one more here. Okay. With practice, this becomes easy, I feel. Okay? With practice, this becomes easy. If you've never done it before, calculate the molality of 5.86 molar ethanol solution whose density is 0.927 grams per mil. Okay, 0.927 grams per mil. Okay, the molality. What is molality? It's moles of solute over what? Kilogram of solvent. Okay, what is molarity? All right, this we know from Chem 1, right? Okay, we all know that from Chem 1, so that's good. But you may not know this from Chem 2, moles of solute over kilogram of solvent. Okay? All right, so what does 5.86 molar ethanol actually mean? Okay, 5.86 molar ethanol actually means 5.86 moles of ethanol over what? Liter of solution. Okay. By the way, what is the solute and what is the solvent here?
Solute is ethanol, solution, or solvent is.
Yeah, we can always assume the solvent is water. Okay, so focus your attention here on this 1 liter of solution. Okay, is it safe to say that this 1 liter of solution is the same thing as 1,000 mils of solution? Is that good? 1 liter is 1,000 mils? Yes? Okay, you got that? Okay, good. All right. 1 liter in our denominator, 1 liter is the same thing as 1,000 milliliters. Right, so I'm going to take that 1,000 milliliters and multiply it by this to get my grams of solution. Okay? Okay. I can get anything. I can get density, I can get mass, I can get volume, but I'm going to use this volume to get my mass. Okay, everyone okay with that? 1 liter is 1,000 mils, so I'm going to multiply that by my density. Okay, this will give me my mass of solution, which is 927 grams, right? Okay, 927 grams of solution. All right. So just like before, just like in our previous problem, we know that grams of solution is equal to what? Grams of what plus what? Yes. Are we okay with that? So our grams of solution is right here. Okay, we got that from the density. What about our grams of solute? Let's take this 5.86 moles and convert it to grams. Okay, can we do that? We'll take this 5.86 moles of ethanol. Okay, and we're going to convert it to grams of ethanol. Okay, you guys know the molecular weight of this. Carbon is about 12.01, plus hydrogen was about 1.01 times 3, plus another carbon is 12.01, plus another hydrogen 1.01 times 2, plus another 16, plus another 1. What do you guys get for the molecular weight? Get about 46. Okay, I'm going to go with 46.06 grams of ethanol. So the moles of ethanol cancel. What's 5.86 times 46.06? 270? Yeah. Okay, we'll go with 270. We'll go with 270 grams of solute, which is the ethanol. Okay, we're going to put that here. Okay, so now we can solve for grams of solvent, right? How will we do that? Okay, we'll take the 927. Let me do this here. So the grams of solution is 927 grams. Grams of solute is 270 grams. Okay, and then we need to get our grams of solvent. So how will we get our grams of solvent? Okay, we'll take 927 minus 270. Okay, 927 minus 270, what is that going to be? $657, which is our grams of solvent. All right, and now I think we have all that we need to solve this problem. Okay. So molality is moles of solute. What is our moles of solute? 5.86, right? Okay, what is our kilogram of solvent? Kilogram of solvent, which is, usually going to be water. What will that be? Okay, this is grams. To convert it to kilograms, we just move it 3 to the left. 1, 2, 3. Okay, so divided by 0.657 kilograms. And this is what our answer will be. Okay. .9. 8.91 lowercase m. Lowercase m. For molal. Yeah, we can do. Okay, so this is our answer. Just like the answer above was 0.429 molar. Okay, so we will, before I let you guys leave, I'm going to skip page 5 and 6. Okay, so we'll skip page 5 and 6, and we'll start on page 7 after we complete these problems, all right? So we'll skip pages 5 and 6. Uh-huh.
Convert it to grams because that's what the problem is in grams.
Yeah, I converted to grams because of this. Grams of solution equals grams of solid plus grams, solute plus solvent. Also, grams because the density is in grams. It's a good question, yeah. Yeah, turn them in paper. Yeah, turn them in paper. And you can turn them in with your group. Just turn in one per group. Yeah, don't turn them in individually. Because whatever grade you get is the... No, the quiz is individual. I mean, that's like really sacred. Uh-huh.